Okay, here we go. The second homework in the course Machine Learning Operations Zoomcamp. This homework is about MLFlow and experiment tracking. The first task is to install MLFlow. Course curators offer to install MLFlow right in Python environment, but I prepare MLFlow installations with Docker Compose tool. In the services directory, you can find MLFlow, Docker file, and assets, including the packet preparation in S3. And as a and I use Minio. It's like it's an alternative to AWS S3, but I can run it locally. So instead of install MLFlow in Python, I will use that Docker Compose installation. Terminate our service. Then I can run MLFlow just with that command, Docker Compose up MLFlow Python. We run S3 service, MLFlow service, and Python Python notebook. The first task is to check MLFlow version. I prepare Python notebook to answer this question. My MLFlow version is version 2.12.2. Okay, the next one. We will use green taxi trip records data set. So I need to load the data. The script will load the data from the folder, taxi data folder. So I need to prepare this data. In my case, I use external data folder because I do everything in Docker. So I have this data directory and I have this green trip data from the Met of 2023. As you can see in prepare data, preprocess data script, they will use that data set named trip data from Met as a test data set. Then I need to run script with data preprocessing. I have already ran this data, and we just need to check directory output to get the information, how many files were saved in output folder. We need to go back to Python. This is our data with source Parquet files. And this is data with output, and we can see that num number of files is 4, so the answer is 4. Train a model with autolog. In this task, we need to modify train.py to turn on the autologging with ML and get the information about minimal sample split. At first, let's take a look at the train.py. So in train.py, I added several code elements. At first, I changed MLFlow tracking URI. I set up an experiment and I add autolog option, and I just need the context manager MLFlow start run. So let's start this script. I also prepared some sort of scenario. With every command I need to run. At first, I need to change directory in my Python notebook. I need to run new Python terminal. Okay, change the dir. Next, we need to run our train script. Let's go to the hits. In the first command with data preprocess. I don't need to run it because I have run it before I started this stream. So let's come back to the terminal. At first, we need to check that everything is good with our MLFlow setup. So we can see here clear MLFlow, and after I run the script, train process, we started. Okay, I just need to change the name of the experiment. Let's name it in this way. Just add some postfix. Let's go back. Start train again. Yeah, now we see that training started successfully. We have some warnings here, but these warnings are not critical for us. Just need to wait a couple of seconds. Yeah, that's it. Training finished. Let's go to the MLFlow interface. Now we can see that new experiment begins, and we have here a log of our parameters. It's parameters from the random forest. We have a lot of useful information, and there is no metrics here. And the question is, what is the value of minimum samples list here? So let's check. We'll use search parameter fork here, and the answer is 2. We have 2 mean sample split here. Two mean samples is the answer for the question 3. Next, I need to launch MLFlow tracking service, but I have already started it in Jupyter. There is no question in this task. And the authors who suggest to use SQLite as backend store, but I use S3 service as S3 store. Next, we need to turn on hyperparameters. We need to calculate root mean squared errors on February 2023 data and come up with validation RMSE error. So let's take a look at file hpo.py. In hpo.py, I also changed the tracking URI, and I add the parameters logging session for every trained models, and that's it. So let's run this optimization file. Let's go back to our hints. Just copy paste this code to the right. So actually this part will take okay. Again, I need to change experiment name from Hyperopt to Hyperopt 1. First Hyperopt 1 or to random forest Hyperopt 1, and let's add this postfix to other experiment names for the future. So let's come back to the model training. Parameter optimization is started here. So I will use this time to fill the answers for second. I just need to copy paste that submission farm URL. This is our okay. The first question was about MLFlow version. And the answer is 2.12.2. Second question was how many files? The answer is 4. Train model with an autolog min sample split. Let's check our latest screenshot. The answer is 2. Okay. I need to answer some question here. What else do you need to pass? Backend store URI. Backend store URI. Let's check out the compose file. Backend store URI. And backend store URI and fold. I think the answer is maybe default artifact root, maybe I think it's artifact destination, but I will check it later. Okay, then we need to check model hyperparameters. Validation RMSEM. Let's go to the interface. We have here this Hyperopt results, and Hyperopt is finished for now. Let's set up these columns. Models we don't know it. Okay, I think RMSE is enough for our task, and we need the best validation RMSEM. Okay, we need to sort same thing, and the best RMSE is 5335, and it's the second answer. 5335. Yeah. Because the best RMSE is on the top, it's the lowest RMSE we have. After all, we need to save the register model. So how to do it? We need the best run ID, and we need to run register model.py. Let's come back to our hits. Let's come back to our hits. Yes, in register model, I just add this part with taking the best tester MCA. And add this register model lines with the best run ID I have. So let's start the register model script. We need test RMSE because as we can see, function logs both validation RMSE and test RMSE, but we need best test RMSE. Right, it's almost done. Okay, the train is finished, so we need that one, random for the best models. Again, we need tester MSE. We don't need the columns. Sort scaling, and the best one is 5.56, 5.567. It's the second one. It's the second one. Okay, and it's also homework URL remaining and loading in public links. So that's it. We finished the second homework.